The saga continues. Part 3, the return of the amperes. The amperes will have to go through challenges again. They will have to go through ammeters. Ammeters measure current. They have a very, very low resistance. They are not a tough challenge. They simply measure I. Voltmeters are a tougher challenge. Voltmeters are designed to be avoided at all point in time. Voltmeters measure voltage. They have a very, very high resistance. We never want to go through a voltmeter. As with all quests for knowledge, it gets more complicated as we go up. We are now going to go through a combination electric circuit. In the combination electric circuit, the ampere family again has 24 volts of potential energy. They have a high potential right here at the positive side and a low potential at the other side of their house. When they leave here, all of the current, all of the ampere family must go through the 2 ohm resistor. There is no options. So therefore, all of the current, I total, is right there. When it gets to this point, the band separates. And we have I4 and I8 are going to go through there. And we know that I total has to equal I4 plus I8. The quest is more complicated than before. Now, the first thing we must do is solve for the R total, because I need to get I total, and I total is equal to V total over R total. Well, I know V total, it's 24 volts. What I don't know is R total, so I must calculate that. Now, when I'm going to calculate that, the first thing I will have to do is combine these 2 parts. They're in parallel, so I must say 1 over 4 plus 1 over 8. Well, that becomes 2 over 8. So 3 over 8. So 8/3 is equal to the parallel part. PP for lack of a better term. So then R total is going to be simply the sum of that plus the 8/3. That doesn't look like an 8. It is. So now I'm going to have 8/3 and 4/3. 8/3 and 8/3 and 2. 8/3 and 2 would be 14/3. So now, let's go to our quest and take it a step farther. 14/3 would be 4.67 ohms. That is the total resistance of the entire circuit. So now, it's 4.67 that goes over here. That leaves me an I total that I can't do without a calculator. And that leaves me a total of 5.14 members of the ampere family. 5 1/7, 5.14. Now, on our quest for knowledge, this ammeter right here is going to read the total current. Everything has to go through there. So there has to be 5.14 ampere family members must pass through the 2 ohm resistor. So therefore the voltage drop across the 2 ohm resistor, we once again go to Ohm's law. Dun 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 dun! And we're going to take 2 ohms times 5.14 amps, which gives me a total of 10.28 volts. 10.28 volts are used up during that part, never to be seen again. It's been converted into other energy. Now, if you think about it, V4 and V8 have to be the same. Well, we started with 24 volts of ancient current. We've used up 10.28 volts of ancient current, which leaves us 13.72 volts. This one is also 13.72 volts, and the math gods are happy. Now, as the family heads off on its quest, we know that 5.14 amps has to go through the top line, go through the 2 ohm resistor. And we know 5.14 amps is on the bottom line after they leave the resistors. But in here, the 5.14 is going to split into those 2 parts. Now, here's where I can use Ohm's law once again. We know this voltmeter over here is reading 13.72 volts. Remember, some of the voltage is used up going through here, never to be seen again. The voltage drop across this branch and this branch must be the same, but it's the leftover part, which was 13.72 volts. Now we need to calculate the current through each one. So if I want to calculate I8, I'm going to use Ohm's law. Dun 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 dun. I8 is equal to V8 divided by R8. Well, V8 is 13.72 volts divided by 8 ohms. And again, that's a number that I can't do in my head. The number is 1.715. So 1.715 members of the Ampere family go through that branch. To figure out the number going through the other branch, you could simply take 5.14 minus that value. But you can also use Ohm's law. Dun 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 dun. I4 is equal to V4 over R4. 13.72 volts divided by 4 ohms is 3.4 amps. 3.4 amps and 1.7 amps add up to 5.7. Oh my gosh. Of course, the family can always use a verb table to help solve their quest. We know that that's 24. We know that that's 2. We know that that's 4. And we know that that's 8. Now we have to do a little math to determine, like we did earlier, that that's 4.67. The fact that that's 4.67, again, if I know 2 things on a line, I know everything. That gives me that this is 5.14 amps. Now, the key thing to understand is 5.14 amps must go through R1. So we can then from that calculate the voltage lost across the first resistor. It's simply going to be 2 times 5.14, 10.28. Move that back up. I apologize for that. Okay, we now know that it must split. Now, one way to think about this, you can do it mathematically and calculate what these 2 voltages are right here. You can simply take these voltages have to be the same since they represent your parallel branches. That's the 13.72 number. You can also do it this way and figure out that 2/3 must go through this one, and 1/3 must go through that one. More is going to go the easier way. So you can do it with ratios. You can also do it with Ohm's law. Dun 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 dun. And they actually both give you the same answer. 13.72, 13.72. 2/3 of 5.14 is 3.4, and this is 1.7. The math gods are happy. To calculate power, you're simply going to take V times I. So voltage times current. When you take 10.28 times 5, you're going to get a little over 50 watts. I'll round these off. If you take 13.7 times 3, you're going to get approximately 45. And if you take 13.7 times 1.7, that's going to give you somewhere in the neighborhood of 20. This would be your brightest light bulb because it delivers the most power. Remember, power is a combination of voltage and current. Next installment, capacitors.